Hello, my name is Professor Johnson, and today I will demonstrate some calculator buttons for you using the normal distribution. So to get to your distribution menu on your calculator, you have to hit the second button and then hit vars. And you see right above vars in blue, it says DISTR. That's our distribution menu. So here's all our distributions. The distributions I am most interested in are distribution number 2 and number 3. Now, number 2 is what's called normalcdf, cumulative distribution function. This will give us probabilities. And if you look at the few questions I wrote up, A, B, and C all ask about probability. So I will be using button number 2 to solve A, B, and C. Now, if you look at D, D is written a little bit differently. It's asking for an X value that represents a top 5%. Now, percent could really be translated into probability, and you could think of area under the curve. So if we were finding the X value, that's when you use what's called invnorm. This is really representing the inverse norm. You can imagine you're doing the opposite of what button number 2 did, normalcdf. Okay, so let's first look at normalcdf. The default setting is the standard normal distribution. As you can see, mu and sigma are mentioned, 0 and 1. That's the standard normal curve. Now, if we look at what it says in lower, that's the lower bound marking, -1 E99. That is representing 99 decimal places to the right. As you can tell, that would be a very large negative number. It'd be -1, 0, 0, 0, 0, 0, all the way through 99 zeros. That's a huge number. That is basically as far left that the calculator can imagine itself going. Okay, if we do a quick little sketch of A, this will help us visualize what's happening here. 14 is our mean, so we'd mark that, and 2.4 would be somewhere over here, and we're looking at the probability less than. As you can see, when you go less than, you're going all the way to the left. So that lower bound would be -1 E99. The upper bound is where you can go to the max. How far up can you go? And you can see you get stopped at 2.4. All right, then you have to tell it what the mu and the sigma were. 14 and 6 are given to you. It goes always in that order, 14, 6. Now, when you hit paste, if you have the TI-84 Plus, you'll see that the menu automatically put it all in. If you have the TI-83 calculator or the non-math print capability, you see that it always goes in this order. It stays. You would just have to hit normalcdf, and then it would automatically start you right here. And you would have to type in -1 E. The E comes from doing second comma, and then you type 99. And then you hit your comma, and you'd put in the upper bound, comma, mu, comma, sigma. When you hit enter, this will be our probability. And typically we round to, let's just say, 3 decimal places. The 5 would bump up that 6. So 0.027 is our probability. As you can see, based on our picture, that value is between 0 and 1. That makes sense. It's that little sliver down there. Okay, let's do a between example, between 2 values. It's always a good idea to do a little sketch. Okay, 20.1 would be above, 8.3 is below the mean, and we want right there in the in-between. So we're looking for that probability, or that area under the curve. So we'll go back to the distribution menu. We'll choose number 2 again. But now the lower bound, the lowest we can go is 8.3. So I'll just over-type 8.3. The highest we can go is 20.1. And the mu and the sigma, you see how it remembers it. If you have the 83, you're just going to type it all over again, unfortunately. But 8.3 to 20.1, that's what we're looking between, mu and sigma. And when you hit enter, this would be 0.674. And as you can tell from that picture, 0.674, if you multiplied by 100, that would give you the percentage, about 67%, and you could see that that makes sense visually to you, and that's the benefit of drawing a quick little sketch, even if it's not perfectly to scale. Okay, let's go on to letter C. X is greater than 30. Now, if we imagine that, 30 would be way up there, because 30 is pretty far away from 14. Way up there, it would be a little sliver to the right. Now notice, we're going to the right forever and ever and ever. So let's think about the lower bound and upper bound. The lowest value would be 30. That's your lower bound. Now upper bound is going all the way up to infinity, basically. I'm going to write something very similar to what the lower bound going to negative infinity was. I'm going to put 1, then hit second comma, that would bring the E. 99 would bring you all the way to the right as far as you could possibly imagine. Mu is 14, sigma 6, just as before. When you hit enter, you can see the pattern. If you have the 83, this should be what you see on your screen. You just have to put commas and everything. When you hit enter, as you could tell, 30 was really far away, so I knew that that would be a small value. 0.004. Really tiny number, 0.004. Not even half of a percent. Okay, so that is all dealing with finding probabilities, probabilities, probabilities. You use normal CDF to find the probability. Now, what if you want to do the opposite? In letter D, I'm given some probability. I need to find the X value. So let me draw a picture of what this is really asking us. Now the top 5%, the top would be over here to the right, correct? And if you mark it and I say, okay, this is the X value I'm looking for, the top 5% is right there. Okay, but 5%, we really need to convert this to probability. To convert to probability, you take the 5% and move the decimal place twice. Or you take 5% and divide by 100. So 0.05, that would represent that little shaded area. Like if we were to find probability, right? Now, I know that 14 is right there at the mean and the center. So I know that whatever X value I get, I expect it to be larger than 14. Now, let's go to our calculator and we will go to number 3, inverse norm. And inverse norm has 3 buttons, or 3 menu options. As you can tell, the default goes automatically to mu 0 and sigma 1. It's asking us for area. Now, you want to think of area under the curve. An area under the curve represents probability, truly. Now, you may be tempted to put 0.05. But let me show you what happens if you do that. This will be wrong if you put in 0.05. You will be incorrect here. So if you see, notice 0.05 really gave you a value, an X value, of 4.13. You see how that's really representing what is right there. That would really represent the lower part. As you can tell, we want an X value greater. This tells me that the calculator, when you go to the menu, is always reading to the left. It wants the area to the left. So the area to the left is needed for the calculator. So what is left of 5%? If you take 100%, subtract 5%, you get 95%. If you convert that, that would be 0.95 for probability. That would represent everything to the left here, right? That would be 0.95. Everything all the way across, which would leave you with 5% up above. So I'm going to put 0.95 into my calculator now, and when you hit enter, you can see the order, the pattern that you go, area to the left, comma, mu, comma, sigma. When you hit enter, 23.8, or 23.9 if we round, 23.9. Now that visually makes more sense to be about there, right? Okay, now if we wanted to check our answer, we could check this by doing a quick probability check, right? If we check, we could do normal CDF, and if we go all the way to the left, -1 E99, comma, and then I put 23.9 as the upper bound, what we just found, and I put in 14 and 6 into the calculator. This should give you what probability? Think about it. Think about it. Pause and think about it. It should give you the 0.95. So let's just check our answer. Normal CDF, -1 E99, upper bound, 23.9, 14, comma 6. Now I rounded 23.9, right? So it may not be perfect, but as you can tell, 0.95. That matches up with what we expected, the top 5%. So 23.9 would be your final answer. Thank you for watching.